let me, well, so I am going to start. Now this is a webinar on benefits, uses, the advantages of a Six Sigma program in industry. So I just want to ask a question is, has anybody heard of Six Sigma? Is anybody familiar with Six Sigma? Amanda, Kathleen?
I'm not.
Yes, I've heard of it.
Okay. Well, I'm going to assume that you want to know what this program is about. And then you can assess yourself and you can ask questions. I think that'll be much better thing to do. So let me just move on to the next slide here. I'm trying to, okay, there it is. So my name is Shri Gupta. I am a certified black belt, and I used to work for Motorola before I retired late last year. And that was my main job in Motorola, to work as a black belt, as a Six Sigma expert. So I would be called in whenever there were problems, big problems. I was working in engineering development team. So this team used to develop, create what are called the two-way radios. So if you've seen the policemen, firemen, when they go around, they have these big, heavy radios, the bigger, overblown size cell phones with them. So those are the ones that were designed in our facility here near Miami, in Fort Lauderdale, Florida. So it is very, very important that we create the products with the right quality, right reliability, and the right cost. So that is where my expertise would come in, to make sure the engineers work at a high level of productivity. They don't really waste time, and you'll see some examples later on what we mean, and that we economize everywhere without compromising quality. So saving dollars without compromising quality, in fact giving a better quality. A lot of time, if you do it correctly, you can provide better quality product at a lower cost. That is what industry is about. All right. So please, I will repeat, if you have any questions, please stop me and holler. So this is a brief seminar. It will go 45 minutes to an hour. And what the organization, some examples, and of course the examples really will be distributed throughout the presentation. And then when you have a Six Sigma program in an organization, what are the roles and responsibilities, what kind of individuals are put in place to make this program a success, and for you particularly as participants, what is in there for you? What value does it bring to you individually as a Six Sigma professional? So I'm assuming that most of the people who are participating have not gone through any formal Six Sigma green belt or black belt education. They have not had a whole lot of exposure to it. So we have a program at Simplilearn. We have a program where you can be certified at different levels of Six Sigma expertise, and in general these are called green belts and black belts. Similar to karate, you have different grades of skills. So of course we are not going into depth of these tools. So this is just an overview to familiarize with you. And we're hoping that this will bring some excitement in you. It will motivate you to go for your certification. Because when you're certified, you have a much wider options to where you can work and apply these skills. So these Six Sigma skills are independent of the kind of industry. So if you go to the hospitals, you'll find Six Sigma experts, Six Sigma programs. You go to banks, you'll find Six Sigma programs. You go to service industry like hotels and all, you'll find Six Sigma programs. You go to manufacturing, you'll find Six Sigma programs. You go to police forces, so safety forces, safety organizations, you'll find Six Sigma programs. So Six Sigma programs are everywhere. And they have caught on pretty well. So once you have Six Sigma skills, then you have many more options open in front of you to find the kind of jobs that interest you. Right? Any questions so far? So I'm going to go into a brief introduction to Six Sigma. So always, when you are coming, you hear this word Six Sigma. What the hell is it? What is Six Sigma? So really, Six Sigma is a quality process. And it provides you a proper structure, a framework to deliver almost perfect products which are very close to perfection. And the definition of perfection really is it doesn't have defects. It doesn't fail. So give an example, I buy a cell phone. So I buy a cell phone. I turn it on. I expect it to work. As soon as I turn it on, I expect to turn on. It should show me all the menus. And when I want to make a phone call, it should make a phone call. And I want to talk for half an hour or 1 hour, I should continue talking for an hour without the call dropping. So if the call drops in between, there's a failure, there's a defect. So when I'm using the phone, it should not fall apart. So the product has to work. It should be available for me to use all the time. So that is what is perfection. So in the Six Sigma is very structured methodology to create very high quality products and services. And there's a series of tools within the Six Sigma program that the Six Sigma professionals are exposed to. They acquire skill in it, they become professionals, they apply these tools to achieve this goal, to make defect-free product or service. So whatever you do, you manufacture a cellular phone, you design a cellular phone, you design a hotel, you design a bridge, you design a road, you make a road, whatever you do, there should be no defect in it. So when you make a road, there should be no bumps in it. When you create a bridge, it should be very even. It should not vibrate, it should not oscillate. So all those kind of things, there should be no defects. Right? And just think, if you're manufacturing 1 million cellular phones, for example, and some phones are defective, and phones are defective, you have to throw them away. So that's the money you lost. So you make 1 million phones, and let's say you have 10,000 phones which have defects in them. So you have lost revenue equivalent to cost of 10,000 phones. Let's say it costs you $100 each. So you've lost like $1 million with the 10,000 phones. So that is very, very important. You do not want to scrap anything. Right. So really, Six Sigma is a process. So why is it called Six Sigma? So that's the other question, and this is what is answered here. Why is it called Six Sigma? Why is it not called 1 Sigma, 2 Sigma? So Six Sigma, in a statistical terminology, sigma is a measure of variation. Anyway, so I'll give an example. If you measure the height of, let's say, adult population in the United States, so maybe the height varies. So some people can be 4 feet, some few inches, some are about 5, some are about 6, some can even go to 7 feet. So you measure the height, so you find a distribution. So there's a variation in height. So sigma is a measure of that variation. So larger the sigma, so the more the sigmas that you have, the more variation you're going to take care of in your process, right? And any variation is a defect, right? So give an example of a variation somewhere. So let's say the cell phone is the color of the cell phone is blue, exactly blue. So some cell phones that you make are not exactly blue, they are navy blue, they are different shades of blue, those are defects. So you don't want that variation. Any variation is a defect, right? So you go away from blue, standard blue, it's a defect. Right? So if you look at the defects, so this is the first column in this table shows you the sigma level, and the second column shows what is called the defects per million opportunities. But very simple, I'll break it down to simple terms. So if I produce 1 million cell phones, how many of these cell phones are defective? It depends on what sigma level I am at. So if I am only at 1 sigma, which is a basic quality level, very, very basic level, out of 1 million cell phones that I produce, I'm likely to have almost 700,000 defective. If I am at 5 sigma level, I'm likely to have about 233 cell phones defective. And if I go to 6, I will have only 3.4 defective out of 1 million units. So it is a tremendous saving. Look at the difference it makes as you go higher, deeper in Six Sigma level. So you can also think of, for example, if you have a very high safety and reliability industry, like aerospace, progresses, and this is how the term Six Sigma was created. For the most of the industry, Six Sigma is a very good number. So you have to remember, the higher the sigma level you go, the cost of maintaining that sigma level also goes up. So it's a cost-benefit ratio. How much are you willing to pay for? Okay. So let me explain it a little bit more. Well, just any questions so far? Is everybody okay with what I have said so far? All right. So moving on. So I'll give you an example. There's a restaurant, and they deliver sandwiches. And the target is that it should be delivered within 30 minutes. All the subs should be delivered within 30 minutes. So now I keep the data. So each delivery I log it in a register or on a spreadsheet. And after a month I take an average and I find an average of 24 minutes. So my average delivery time is 24 minutes, right? And my target is that all the subs should be delivered in less than 30 minutes. So I have a question for the team. And please speak up. Unmute your phone, unmute your computers and then your microphones and then speak up. Do you think that all the customers were happy with this restaurant where the average delivery time was 24 minutes? Do you think the restaurant did very well? Any answers? Come on, somebody should. I don't hear anybody.
Hi, this is Kathleen. I think the restaurants would, the customers are pleased, but I think that the time could be improved.
Okay, thanks Kathleen for speaking up. Well, so here let me show this, right? So average may be a misleading metric. So I'm trying to move to the next. Okay. So this is, and that's what I've shown in the next chart here. So you see the distribution. The horizontal line is the delivery time, and the vertical, and this chart here. Did somebody say anything? Okay. Okay. Well, so please mute your phones if you want. I think some phones are unmuted. This is not phones. So microphones are unmuted. So this curve. I'm hearing somebody is not muted. So this curve shows for each of the delivery times, how many customers saw the delivery time. So this one here, for example, 10-minute delivery time, which is excellent, was seen by, if I draw a vertical line here, so many customers, and I don't have the numbers here. Let's assume that it was 5 customers. 20-minute was seen by 20 customers. 24 minutes, which is the average, was seen by maybe 30 customers, so on and so forth. So if you see 30 minutes was seen by about 20 or so customers, but there were also customers which saw more than 30 minutes. So this is how the distribution is. So if I add all of them up and take an average, I get an average 24 minutes, which is better than 30-minute target. But you see this blue area, all this, the customer saw more than 30 minutes. So guess what? I didn't meet the target in this area. So many customers saw more than 30 minutes. So this is how we work in Six Sigma. We understand what the average means, and we understand what customer satisfaction means. Customer satisfaction means none of the customers saw 30 minutes or higher. So of course you'll have unhappy customers, and these customers might go to other restaurants and I can lose them. So if I don't handle it correctly, I could lose, and I will not understand. My average was so good, it was 24, it's 30, and still I'm losing customers. So that is an example of Six Sigma here. Okay, so I want to move on. Some reason my computer is a bit slow. There it is. So there's another example here, and you see the same kind of chart. There's two charts. So 1 month you have the black line, and another month is dashed red line. So these are different distributions. And obviously you'll see the red one, so this month is much better than this black line month. So as soon as I draw it, I can compare. So I can see the average is lower, the average is 60 something, and here the average is about 105 or something. Plus the variation here is much narrower. You see the minimum to maximum here is from 0 to 100. In the black line, the minimum from 0 to 150 almost. So the variation in black is too much also. So this process is not good. So I make an improvement. So here how the story works. So initially my process was following this black line, and I found that I'm losing customers, my business is not doing well. I draw this chart, I see the problem, then I do something, make improvements, and I get this red chart. So when I get to this red curve, my data, and I see I get more customer, more business. The process improved, and of course, if you have a much better process, you'll have better customer satisfaction. Okay. Are you with me? Some more examples of Six Sigma. So if you have 3 Sigma level versus 6 Sigma level, so real life things. So in a country, if it is working, if the airports are working at 3 Sigma level, they're likely to have around 964 flight cancels in a day. However, if it is a 6 Sigma level, only 1 flight in 3 weeks rather than a single day is likely to be canceled. A big difference. Same thing, if babies are dropped in a region, about 5,400 babies are dropped each year in the 3 Sigma level. At 6 Sigma level, there will be only 1 drop in 4 years. A huge difference. And look at the phone calls. So if you had 3 Sigma level, you're likely to have 47,283. Of course, there's some assumptions behind this. 47,283 overseas calls disconnected in an hour. But at 6 Sigma level, it would take more than 2 years to see the same number of calls drop. So from 1 hour to 2 years, such a huge difference. So that is why, and depending on your needs, this is the investment you have to make to bring your process, your industry, your business to a 6 Sigma level. Quality started growing after the Industrial Revolution. Of course, the things were very basic in the early days of the Industrial Revolution, mostly in Europe. Then as the industry grew and came to 1930s, when this SPC, something called statistical process control, was introduced, then people started coming up with new methods of improving the quality and different names. Quality circles, ISO 9000, Baldrige Award, which is a US-based award, Malcolm Baldrige Award, benchmarking, scorecard, region, and there's different names. Again, I mean, if you're interested, you can go through these things and you'll find a lot of information on the internet for each one of these. So 6 Sigma is part of quality. So I went through the very brief bird's eye view of the quality, and now into Six Sigma, history of Six Sigma. So Six Sigma as a concept was initiated by Motorola back in the 80s, 86 to be more precise. A couple of guys, they introduced the concept, and this was mainly driven by manufacturing. So the amount of scrap being created in manufacturing, amount of rework being done. So rework is you make a part and there's a defect, so you can perhaps repair it. So you have to hire some people who will do extra work to remove the defect. And sometimes you cannot remove the defect, so you have to scrap the part. So either way, you lose money. When you rework, you're losing money, and you scrap, you lose money. So this is what. So this is how it was started. And you've seen earlier, if you're working at 1 Sigma or 3 Sigma level, there's a high number of rejects, defects that are created. So it was to remove those rejects and defects that this process was initiated, and became very successful. It was in industry, it was a very, very highly appreciated news about the introduction of Six Sigma. Then General Electric picked it up. Jack Welch in General Electric picked it up, and he applied it in manufacturing, and he said, no, I don't want to limit it to manufacturing. I want to apply it to my other areas of business. So he applied it to his engineering and development teams, the product, service, everywhere, and he was highly successful. And then many other companies like Signal, and then many more companies, and there's a, you go into Fortune 500, and they're very difficult to find a company which does not apply or use Six Sigma principles. Right? And you can see the saving, the amount of saving that each of the company has affected using Six Sigma programs. Right? Billions and billions. And of course, I've worked in Motorola, I've worked in industries, and I've seen it myself. And the project that I've worked in, we've saved hundreds and thousands and millions, and this is how it was. Right. Okay, so what is within Six Sigma? What does Six Sigma program contain? Again, this is a bird's eye view, and if you want to go into depth, you probably have to register for some of the Simplilearn courses. And Simplilearn has for each one of these appropriate courses for certification or for general learning. So there are 3 processes in Six Sigma, the 3 different branches. There are many more, but in general, high level, these are 3 branches. One is called DMAIC, DMAIC, the other one is called DFSS, Design for Six Sigma, and the third is Lean. And I'll explain a little bit more for each one of them. The first, so out of these 3, the first DMAIC. So what is DMAIC? It's a very strange name, very strange term. So this is an acronym. DMAIC is an acronym, and you expand it, it's in the circle here. D, define, measure, analyze, improve, control. You take the first letter, and that's DMAIC. So this is how it is done. You define a project or a problem. You define it, so you understand that, and I give an example. I mean, I start making a new cellular phone, I ship it to customers, and lo and behold, I have a high failure rate. I get 10% of the phones failing in the field, in customer hands. So I define a problem. My problem is 10% failure rate of phones in customer hands. And I also define a team that will help me work on this. So I get the right experts that will help me work on it. So I'm a black belt, and I get a mechanical engineer, electrical engineer, a software engineer, etc., put a team together to help me find the problem. Then the next phase I go is, once the team is formed, is measure. So I create a bench line. So benchmark, I'll create my baseline data. So 10%, what kind of phones, where do they fail, only in the northern United States, do they fail worldwide? So I gather all my data. So that's called the measure phase. I measure where I am at. Then I do the analysis, which is called the root cause analysis. I try to find why are these 10% failing? What has happened? Is it because my software was defective? Is it because their customers have not been trained enough and they make mistakes in using the phone? Is it my supplier supplied me a very poor quality of displays or keyboards or keypads? So I find the root cause. That's the analyze phase. Then improve phase. Once I found the root cause, then I go and fix it. So it's a software defect. So I get the software teams, they look at the defect, they work on it, they fix the defect, and send out the updated software package to all the customers. Control phase is the learning phase. What have I learned from the problem, from the issue? And I make sure that future it does not happen again. So this is the DMAIC. For each phase, the specific statistical tools that are used. I will give you a bird's eye view of some of these tools as well later on. So that is the DMAIC process. The next one, DFSS, Design for Six Sigma. So this DMAIC is used really when you want to improve something, which is the manufacturing. So field failure, I want to improve the field failure rate, so I apply the DMAIC process. In manufacturing, my defect rate is very high, so my scrap rate is very high, my rework rate is very high, and I apply my DMAIC process to improve those rates. DFSS is totally different. This is when I'm designing a new product. So there's no question of any defect in it, but I want to create a new product which has no defects in it. So when I ship it, it can be manufactured very easily, and when the customer uses it, he doesn't see any defects in it. So that is the DFSS, Design for Six Sigma. So you can apply it for a product or a service. Okay. So this is how this works, Design for Six Sigma. Is everybody okay so far? Any questions? Comments? So the third Six Sigma is the Lean. Lean is of course a very simple concept, but this is where so whenever you're doing something, there's always some non-value added activity, some waste. Right? So you just want to eliminate those non-value added activities and the waste. I'll give you an example. When you go to a grocery store, in the supermarket, and I've seen that personally. I mean, if you go to Walmart or something, and sometimes you have a long line at the checkout counter. So you're waiting there. So that waiting time is a waste. It's not only for you, but also for the retailer. It's a problem because if you're waiting for 20 minutes, if he had more efficient checkout process, he could have checked on many more customers, because some customers might just walk away because the waiting time is too long. So eliminating waste. So another example of how the Lean concept works and the Six Sigma process works. So imagine this is from a welding technician. So he's welding some parts, and he notices that some parts that come in that he has to weld have rust. And what happens is when there's rust, you cannot weld them properly. You have to remove the rust. Happened is that there should have been no rust in the first place. Right? So perhaps the rust was because the part came in about a month ago and was lying in my inventory, in my warehouse. And my warehouse had high humidity, so it was rusting. The part was rusting. So I can do a couple of things. I can buy the parts maybe a week in advance rather than a month in advance. Or I can change the environment of the warehouse so it doesn't rust. And I can save all the cost of this traditional solution. Right? So this is how this is another example of how this process works, Six Sigma process works. Okay? So the Lean, and this is really, a lot of these concepts came from Japan. and you'll see a lot of Japanese terms. So non-value-added activities is really three ways. Some like non-value adding work is really the example that I've given you previously. Also like waiting time, unevenness, overburden. Again, this is again a very high-level view for you. When you attend the course, you'll go much more into depth of some of these concepts. You'll appreciate much more. All right. So those were the three. Again, the three. Let me just go back here. The three Six Sigma methodologies. Very, very important. DMAIC, DMAIC process, where you improve the quality of the product or process or service. So that is the DMAIC process. Second thing is the DSS, Design for Six Sigma. Here you create a defect-free product right from scratch or a service. And the third is the lean concept, where you eliminate waste. In just general terms, eliminate waste. So these are the three main branches of Six Sigma. And each one has its own tools. And literally there are hundreds of tools. But there are some tools that are used much more often. And we'll see a few tools here in this presentation. So in a Six Sigma program, the most important thing is the program has to be accepted by the management. It has to be driven top down. So the top executives, so this is how the teams work. So the top executives drive it down. So top executives are convinced that the Six Sigma will bring in value to the organization. They introduce the program through champions. Again, these are senior people. They appoint champions, and the champions make sure that the Master Black Belt, this is the highest level of Six Sigma certification that the Master Black Belts are in place. And each Master Black Belt oversees a bunch of Black Belts, and each Black Belt works together with a bunch of what are called Green Belts. So this is how the whole responsibility works. And you could have different reporting matrices, and different organizations work differently. But essentially these are the roles that you need. Top executives, champions, Master Black Belts, and Green Belts in a program. Okay, everybody with me so far? Any questions? So what are some of the tools? And you see a lot of acronyms here. And I'll show you a couple in the next few slides. So now the DMAIC, DMAIC in the DMAIC process, so each of the phases, there are different tools that are used. So there is SIPOC, VOC. VOC stands for Voice of the Customer, and that's exactly what it is. What does the customer want? What are customer requirements? That's the VOC. There's a FMEA here lower down, which is a failure mode and effects analysis, which is failure modes. So really this is a tool to anticipate what can go wrong in my manufacturing or in my design. Again, I'm not going to detail all of them. It will take several hours if I want to go through them. But again, if you decide to do the course, you'll get exposed to most of these. In the measure, there's different kind of charts. There's gauge studies that are done. Gauge is measurement system studies that are done. CP, CPK, these are capability studies that are done. In the analyze phase, SLR, and we have an example slide later on, is the regression analysis called. This very interesting, something very interesting is called the fishbone diagram. You'll see one of them is called the cause and effect diagram. There's some tools that you probably have heard in Proofread, like brainstorming, etc., that you probably know. They use widely. And there are control charts, control plans, etc. So there's several tools that are used. And of course, there are many more tools that I have not put down here. These are some of the main ones. Okay, so remember that among three, DMAIC, DFSS, and Lean, DFSS has a very important tool. It is called the quality function deployment, or the house of quality, is better known as the house of quality. House of quality is really conversion of customer requirements, what customer wants, customer needs, into engineering language. So whatever the engineers work with, the engineers work with totally different kind of words and concepts. Right? So give an example. A customer says, and there's a customer offers cellular phone. So customer says the phone should be very light. It should fit in my pocket. The phone should not drop a call. Engineer is not good enough. It should be very light. So what does it mean? So for engineer, the phone should be less than 2 ounces. So that's what makes sense to engineer. Phone should fit in my pocket. So again, definition. So phone should not be larger than 3 inches by 6 inches, something like that. So the engineering language is in inches, ounces, pounds, etc. For customer, it is an experience, lightness, fits somewhere. So this is what the house of quality, this is what we do. Right? And there's an example how this works, but I'm not going to go into this. So on one side, we put down what does the customer want, and this is how does an engineer design the product. Right. Moving on, another tool. So that was the house of quality, QFD. This is the cause and effect diagram. It's also called a fishbone diagram. And there's another name from the inventor of this diagram. It's called Ishikawa, Japanese name Ishikawa. He's the gentleman who created this the first time. So it's very simple. You're trying to find out all possible causes of some defect or some issue that you've seen. So here, this is an example, is an organization is producing software applications, and they find a problem. They find that in spite of all the testing of the software, inspection and testing that they do, in spite of it, some defects leak into the production. And of course, they get into the customer hands. So the engineers sit down and they create this diagram. So what they've done is defect leakage into production. That is the issue. So that's the effect that's going on. So what are possible causes? And you can see it looks like a fishbone. So it is divided into these co-development team could be causing it. It could be their skill set. It could be their knowledge set. It could be the other thing. It could be ineffective reviews that happen, incomplete test case, etc. So this is how this is created. Once this is created, you know these are all the possible causes, and then you go into one by one, and through your testing, you eliminate each one of them, and then you focus on the main ones. Again, if you decide to do the course, then you will get more exposure into this and more practice into this. So that was the second tool, which was the fishbone diagram. The another tool is called a scatter plot. So you plot two variables against each other. So here is an example. Again, it's a hypothetical example. So corporation's revenue versus the number of employees. So is there any relationship between the two? If I hire more people, is my revenue going to go up? Right? I want to decide, I determine that. So we take the data. So take 1, 2, 3, 4, 5 data points. You put in this plot. So when I had 100 employees, my revenue was this. When I had 60 employees, my revenue was 350. And I put these points, and I see, oh yeah, it looks like there's a trend here. And of course, the software, the Excel mostly the Excel. That's what we use in this. And you can ask Excel to draw what's called the regression line among this. And what the Excel does is it draws a line, and people who have done a little math in the past, it even gives an equation for this line. It says y, which is the vertical axis, equal to 2.457 into x minus 33.418. Is it minus? I thought it should be plus. Anyway, so it gives you an equation here. So once you know the equation, you can project it further. So if I have 200 employees, what is the revenue I can expect from the way my company works? So you can predict, and you can use as justification to hire more people. So if I have more money, if I can borrow money or get from the investors, and you show them this curve, this graph, it might be easier to convince them. So there's different ways you can use these tools. Once you know the purpose, you know the issue, you would go and gather the data and create the chart, do the analysis. So this is how the Six Sigma works. Again, you can go much more into depth of Six Sigma when you attend a course, right? So we have, I think, 4 days courses. Black belt is a bit longer, and there's exam with it in the course. So any questions so far? Is everybody with me so far? Okay, so that's all. I wanted to just give you a very cursory overview of how Six Sigma process works, what is it all about, some examples, and these examples are scattered throughout the presentation. And I just want to do a little quick summary now. Let's look at the benefits of Six Sigma. So really, there's an issue, there's a problem, there's a defects, there's failures. So Six Sigma helps us get into the root cause of those failures, those problems, those issues. And if you're creating a new product or a service, Six Sigma helps you to create a defect. So that is how the Six Sigma process works so far. Now, what is in it for you as a professional? So why would you want to become a Six Sigma professional? Why would you want to attend a course, go to the exam, do some projects, get a certification? What is in it for you? Just remember, once you become a Six Sigma professional, you have been armed with an additional set of tools which help you improve the efficiency, which help you improve the bottom line, which help you improve the top line of the organization of the business. It helps you increase the revenue of the business. It helps you reduce the costs in the business, whether it's manufacturing, whether it's a design, development, whether it is providing some service to the customers, whatever it is, whether it's a front desk reception in a hotel, whatever it is, you improve that service or the product, which is a great value. So there's only few people, mostly in an organization, which have this skills, and they moved around into the problem areas. So it is a very valuable certification, and I call it a degree. So if you become a green belt, it's like a degree, a college degree. You become a black belt and you get the certification from a reputed organization, like Simplilearn is, then you get an additional degree, which is valuable for any job you do, or any future job that you want to do, or any business that you want to create. No matter where you are, you apply the skills. So right now, after retiring from industry, I have my own business, bookkeeping, accounting, and I apply this in my business, these concepts, these tools, to improve the business, and in fact make my life easier, my workload easier. So it is, again, it is valuable degree for you. You become a valuable, much more business of that organization when you acquire this degree, certification. It's a very, very good skill to have. So that is the part of Six Sigma mostly. So any questions so far? Any questions, comments from participants, from the audience here on this webinar? Well, I think I have a couple more slides about Yeah, sorry, go ahead. Somebody said something?
I thought you were wrapping up, so I was just going to say thank you. That's it, but go ahead and continue.
Yeah, well, yeah, thanks for saying it. There's only a couple more slides here. There's much more about Simplilearn. So, somehow you got to Simplilearn and you signed up for this webinar. And so the Simplilearn is quite a large organization. It's a global organization. It's mostly training, and it's trained over 100,000 professionals in many branches throughout the world. And you can see these dots. Of course, there's not enough dots here because it's a small view of the atlas. And of course, on their website, you can do live chats. You can find out. You can talk to them, and you figure out whether something interests you, how the whole process works. And they keep holding webinars for all the professions. This is a quick overview of the different areas that they train in. So project management, big data, finance, SAP, software, Microsoft. This is the Microsoft tools, Excel, PowerPoint, those kind of stuff. Quality, ISOs, and Six Sigma that you're looking at, and several related to IT, and again, Agile, and again, related to software. So there's many. And what is in it for you. So anyway, if you have any questions and you think of any other questions later on, please feel free to contact the Simplilearn through the chat, through the email access they have. Shoot out your questions, your comments, and we will do our best to answer them. So if there are no more questions or comments, thank you everyone for attending this.
Thank you.
And hope to see some of you soon.
Thank you.
And hope to see some of you soon.
Thank you, Sheree.
Okay then. Bye-bye.